So just like in our second question where we dealt with confidence intervals, our second example of our hypothesis test gives us data as opposed to summary statistics. So again, we see some of the keywords that we're used to seeing, and feel free, of course, pause the video, try this on your own, and come back and see if you did it correctly. But we see some of the keywords that we know indicate a hypothesis test. We see claim, and then we have a claimed average. So this is going to be the mu that goes into our hypotheses. We could even already start writing that in. So they claimed it was 18. And we know our alternative is still going to have to do with mu, still going to have to do with 18, but we're going to look for a direction. A researcher wants to test this claim. So again, another keyword telling us we're doing a hypothesis test. She took a random sample of 10 adults. So our n is equal to 10. And here they are. We got our evidence. And again, this is amount of time spent per week on leisure activities, which is a quantitative variable. We're told to assume that the time spent on leisure activities by all adults are normally distributed, and use a sample to test the claim. So again, we got the word test. So normally distributed is letting us know that we do indeed have those three requirements, right? We do have our simple random sample, which means that our values are independent. Our n is less than 10% of the population, and while 10 is a very small sample size, the normally distributed nature of our population means that we can indeed use a t distribution to test this. And we're going to have to use a t because the only thing we can get from a sample is an x bar and an s. No keywords here saying we think it's more, we think it's less, and we don't even have an x bar right now to make us feel a certain way. So we're going with another two-tailed test. So if this is the question, just like in the question for the confidence interval, we're going to have to go find this information by doing one var stats. So we enter all this data into, I need to turn it on first, into a list in our calculator, whether we have the big calculator or the little calculator. So I'm going to clear this out, enter the list, and this is true for both groups, people with both calculators. Just from, I screwed up, damn it, 26, and I'll just put 19 down here. Based on these things that I'm entering, it looks like our values are higher than that 18, right? I got 10 in there. We only have two values in the entire sample that are less than 18, so I'm guessing that it might actually be something greater, but we'll figure this out. And again, I don't change my alternative based on my data because that is made up ahead of time. So one var stats, 25.7. That is not what I meant to do. One var stats. I meant to go change this thing to green. 25.7. And then my standard deviation is 9.0437. And I know that it has that sigma on that output, but that sigma, I don't like how that looks, sorry. That sigma is based on population data, and we definitely have a sample, so we should be grabbing x bar and s. So we've done step one. We now need to look at our evidence and see, is 25.7 far enough from 18 that we can reject the statement that it is 18? This is the whole point of the hypothesis test. So we thought it was 18, or this past study claimed that. We went and took a sample. We ended up with 25.7, which seems real different than 18. Unfortunately, though, we are doing a two-tailed test, so we're going to have twice the p-value. And then, of course, we can go get our test statistic, which is our t x bar minus mu. So how far is that x bar from mu in terms of our standard deviation or standard error? And that's 25.7. How far does that differ from 18, which will be a positive z-score or t-score, because that's what we're dealing with. And then we also have our standard deviation all over the square root of n. And those of you with the big calculator, you're just doing t-test. So I'm going to pause the video. I'm going to give you the answer. All right, so that t would be 2.692. As always, if you haven't tried typing this stuff into your calculator, really, I emphasize that you do it because there's a lot of mistakes that can happen. Just make sure you put big old parentheses around these if you're not using the fraction button in a 36X Pro. If you use the calculator and t-test, you've already gotten both these for free. I'm going to do the walkthrough again of the table just in case anybody needs it. So with the table, we're going to the t table because we have a t, and we need our degree of freedom, which is going to be 10 minus 1 or 9. So we're going to be searching the table on degree of freedom 9 row for about 2.7. So I'm going to go over my table. Degree of freedom is 9. We're on the hunt for 2.7. So going along this row, 2.7 is right between those two values, which will give me a tail probability of somewhere between 0.01 and 0.02. So I'm going to write those down. Our p-value is between 0.01 and 0.02, always writing the smaller value first. But since we have a not equal to, we're going to do a times 2 on this. So our actual p-value is between 0.02 and 0.04, which is exactly where this p-value is that the calculator folks got. Step 4, since our p-value, oh, they didn't give me an alpha, let's go ahead and just use an alpha 0.05 because it's sort of the most common, is less than that. We're going to reject the null. It's also the smallest p-value where we can actually have something statistically significant, smallest alpha level. So that's why I would choose that if I were in this position too. And we can say at a significance level of 5%, there is enough evidence to conclude, and this is that the leisure activity, the mean leisure activity, so I could just say to reject the claim, but I'm going to go ahead and write this with the words, because I didn't do that in the last one, that are all this alternative hypothesis in words. So to conclude that the average or mean, doesn't matter, amount of time spent on leisure activities, I'm just going to move it to the next page, sorry guys, activities, and this is per week, I assume, per week, for all adults, because that was our, we were just talking about all adults in America. And again, I'm being really good about this. I'm making sure that I'm clarifying that the thing we cared about is the average, that it's for everyone. This is the parameter. And then even making sure I'm telling you guys what my population was. So I'm being really good on this. I'm usually not this anal retentive when I grade yours, but just wanted to make one nice and pretty. Is between, oh God, dang it. I hope started doing a confidence interval all of a sudden, had a brain fart. Is not 18 hours per week. And I guess I didn't need that because I already had the per week. So boom. All right, so is not 18 hours is coming from here. So again, you could have just said reject the claim from the past study. That would have been clean and easy, but this is technically saying all the right things. Remember I said we want to make sure we have the word average, something about this being the real deal, and then making sure we put units in there as well.